Okay, so we have to check if two trees are identical. We're given two trees and we have to check if both of them are identical or not. Okay, so two trees are said to be identical if they have the same data and structure. So in the function we return 1 if the trees are identical, else we return 0, that is if the trees are not identical. So let's take an example. We're given two trees. As we can see, both of these trees contain the same data as well as they have the same structure. So we return a 1 signifying that the trees are identical. Okay, so let's discuss the algorithm to solve the problem. Check identical is the function that we use. It's actually a recursive function. I return 0 or 1 depending on whether the two trees are identical or not, hence the return type int. There are two parameters to this function. Node 1 is the current node that I'm considering in tree 1, and node 2 is the current node that I'm considering in tree 2. So essentially, when I begin the algorithm, I call the function check identical with the root of node 1 of tree 1 and root of tree 2. So this is initially when I call the function for the first time. Okay, so if node 1 is equal to null and node 2 is equal to null, I return 1. So this identifies the case when both the trees are empty. So if both the trees are empty, both the trees would be identical and I return a 1. On the other hand, if node 1 is not equal to null and node 2 is not equal to null, that is, both the trees are non-empty. So essentially, in this case, either they can be identical or they may not be identical. So let's just see what we're doing over here. So I return this value. So let me talk about this value. Okay, so if this value is 1, then I return 1, which means that the trees are identical. And if I return a 0, that means that the trees are not identical. I'll return a 1 if all three conditions are satisfied. So let's discuss the conditions in detail. First of all, the current node that I'm considering is node 1 and the current node I'm considering in tree 2 is node 2. This is for tree 1 and this is for tree 2. Okay, so essentially the data element should be the same. That is, both the nodes should have the same data. The second condition is that the left subtrees should be identical. The third condition is that the right subtrees should be identical. So essentially, the three conditions that I'm going to use is, so this is node 1, this is node 2. Both these nodes should have the same data. Also, the tree left of node 1, that is the left subtree of node 1, should be equal to the left subtree of node 2. Also, the right subtree of node 1 should be equal to the right subtree of node 2. So if these three conditions are satisfied, I return a 1, signifying the fact that both these trees are identical, else I return a 0, signifying that both these trees are not identical. Okay, so this is the case where they can be identical or they can be not identical. In this particular case, they were identical. But what happens if node 1 is equal to null and node 2 is not equal to null, or node 1 is not equal to null and node 2 turns out to be equal to null? So in that case, I return a 0, signifying that the two trees are not identical. So If both of these cases aren't satisfied, I go on to this particular case, which has these two possible subcases.